This video will cover the concepts of simplifying radical expressions. To begin, we must come to a common understanding of what is meant by the term perfect square. Perfect square is any rational number that is the square of another rational number. In other words, the square root of a perfect square is a whole number. For example, 0, 1, 4, 9, 16, 25 are all perfect squares. That's because, for instance, 0 can be thought of as 0 squared, or 1 could be thought of as 1 squared, or 4 as 2 squared, and 9 being 3 squared, 16 being 4 squared, 25 being 5 squared. The next one would be 36, which is 6 squared, and then 49, and then 64, so on and so forth. With our previous definition in mind, take a moment to identify the perfect square in each set. Pause the video and give it a try. Did you choose the number 81 for the first one? It's 81 because 81 can be thought of as 9 squared. Pause the video and try the next number. Did you choose 25? If you did, good job. That's because 25 is 5 squared. How about the next one? Pause the video. Did you choose 256? If so, good job. 256 is 16 squared. How about the last one? The last one is 196. That's because it is 14 squared. But what about those numbers that aren't perfect squares? Like the square root of 24. Can we do anything with that without a decimal approximation from a calculator? Yes, we can. We can actually get an exact representation of it. And these are my preferred steps for doing so. So we're going to break down the number under the radicals using a factor tree. So 24, I will factor that into 2 times 12. 2 is a prime number, but 12 I can factor further. I'll factor 12 into 2 times 6, and then 6 into 2 times 3. I'll now write the 24 as the product of 2 times 2 times 2 times 3. For the next step, I'm going to pull out pairs from under the radical. I've made the analogy before that it's kind of like breaking out of jail, where two of the same thing can dress up together and sneak out as one. I don't know how that has to do with jail, but it's fun to think about. So in this case, I can grab 2 of the number 2's and I pull them out in front as a single number 2. Now, the mechanics behind that really have to do with something like this. I can rewrite 24 as this, the square root of 4 times the square root of 6. 4 times 6 is my 24. Then the square root of 4 is 2. And that gives me 2 square roots of 6. We're going to end up with a similar result in just a moment. So now for the last step, we write the result by multiplying all the numbers on the outside of the radical and all the numbers under the radical. So I only had my 2 on the outside, but underneath the radical, I still had a 2 times 3. So that 2 times 3 gets multiplied together to give me my 6. If there were other numbers out in front of the radical, I would multiply them as well, but there's only the one number, so it just stays as 2. Let's try another one together. Let's do the square root of 48. Well, 48 can be thought of as, let's see, 6 times 8, and then 6 can be written as 2 times 3, 8 can be written as 2 times 4, and then that 4 can be written as 2 times 2. So now the square root of 48 can be thought of as the square root of, let's see, we've got a 2 times 3 times 2 times 2 times 2. I'm going to put all the 2's next to each other. 2 times 2 times 2 times 2 times 3. I look for the ones that can come out together. I've got a pair of 2's here that can sneak out together. And I have a pair of 2's here that can sneak out together. So that means this turns into 2 times the 2. Well, let me go back and use my colors so they stay the same. This other one was the one that came out from the blue circled 2's. And then under the square root, I still have the square root of 3. This can simplify then by multiplying the 2's together to give me 4, and then I have the square root of 3. Pause the video and try the square root of 18 on your own. Did you get 3 square roots of 2? We have the 18 factored into 3 times 3 times 2 under the radical. The two number 3's sneak out together as a single 3, and then there's nothing left to multiply. Try the square root of 360 on your own. Pause the video and give it a shot. You should have gotten 6 square roots of 10 for your final answer. We get that by factoring 360 into 2 times 3 times 2 times 3 times 2 times 5. A pair of the 2's can sneak out together, and a pair of the 3's can sneak out together. So I have a 2 times 3 out in front, and then that becomes 6. And under the radical we get 2 times 5, which is 10. This same thought process can be used when there are variables involved. To do this, we again pull everything apart. So for instance, for our first example, for x, the square root of x cubed times y to the 4th, I would break this down into x times x times x, that's my x cubed, times the y to the 4th would be y times y times y times y. Now, with that in mind, I can pull out a pair of the x's out in front, and then 2 pairs of the y's can come out in front. So that leaves me then with an x out in front, a y, and another y. Left under the radical is the x. Now I'm going to simplify this as x times y squared, because of the 2 y's, times the square root of x. You try the next one on your own. You should have wound up with a times b squared times the square root of ab. We had a pair of a's that came out together and 2 pairs of b's that snuck out together. Then we simplified what was out in front of the radical, and what was under the radical was nothing to do there. Try the final one on your own. Pause the video. You should have gotten 4 times a times the square root of 3b. The 48 we have already broken down before, but to do it again, it breaks down into 2 times 2 times 2 times 2 times 3. I broke it down in a little bit different order than the previous slide, but notice the result comes out the same, because order doesn't matter with multiplication. And then we have the a times b from the variable portion. A pair of 2's can come out twice, and the pair of a's can come out once. So then we are left with a 2 times 2 times a in front. The 2 times 2 becomes 4, and then we are finished. Sometimes we'll even have a number out in front and a number under the radical. We handle this much the same way. It doesn't change our strategy much at all, really. So what we're going to do is we'll break apart that number underneath again. So this is just going to become the 4. Nothing's happening there yet. And then under the radical, well, let's see, what can I take into 72? I could do 8 times 9. And then we can turn this into, the 8 can be factored into the prime numbers of 2 times 2 times 2. And the 9 can become 3 times 3. So those are all prime numbers. I could have used a factor tree on that 72 as well. It worked out the same way. I just didn't draw out the branches of the factor tree here. And now underneath I can sneak out a pair of the 2's together. And I can sneak out a pair of the 3's together. So that then leaves me with that same 4 out there. Wow, my marker got pretty thick there. The same 4 out there. And a 2 that I snuck out. And a 3 that I snuck out. And left underneath the radical is just that 2. So I've got 4 times 2 is 8, times 3 is 24. Square roots of 2. There you go. I hope that helps you a lot. Good luck and have fun.